Welcome to this Center Math Problem of the Week. For this week's problem, we want to find all positive integers mn such that we can cover an m by n board with 3 by 1 and 2 by 5 pieces. So the first thing we're going to do for this is show how we can cover a wide class of boards. So first we're going to consider boards that have both m greater than or equal to 4 and n greater than or equal to 10. So these boards, note we can always fit 4 2 by 5 pieces there. And note both 2 and 5 are congruent to -1 mod 3. Let's say we have some board. So say we have some board, L1 by L2, m by n. We can cut out a little corner here, 4 by 10, where we can put 2 by 5 pieces. So note, if any of the sides are congruent to 0 mod 3, you can just fill it up with the 3 by 1 pieces. So let's say one of the sides is not congruent to, neither of the sides are congruent to 0 mod 3. We can always, if this is congruent to 1 mod 3, if we have 1 2 by 5 here, this becomes congruent to 0 mod 3. If this is congruent to 1 mod 3, this 1 2 by 5 will also put to 0 mod 3. And any arbitrary combination of 1 or -1 mod 3 that these are congruent to, we can place 2 by 5s here, so these two, this section and this section will have a side congruent to 0 mod 3. And so when these two sections have sides congruent to 0 mod 3, specifically the bottom here and this side here, this will also have sides congruent to 0 mod 3, and so we can fill up this whole thing. And that shows us how if we have both m greater than or equal to 4 and n greater than or equal to 10, if both of these are true, we can fill up the board. So now we can do some casework. Take our larger side, let's assume it's n, so m less than or equal to n. We can look at m equals 1, 2, all the way to 9. And with each of these, we can just do some casework. A lot of these are straightforward in filling up the board. Note when m hits 10, n is greater than or equal to 10, we satisfy our previous conditions, so we don't need to look at that. With each of these, the filling it up is very straightforward. It's fairly simple to see which ones you can't fill. The one that's a little bit tricky is 4 by 7. So yeah, the 4 by 7 we can also fill up, put 2 by 5 in the center. Note, put a 3 by 1 here, 3 by 1 here. 2 3 by 1s makes 6, plus 1 here makes 7, and you can fill this up. And so the only ones we cannot fill up so the only ones we cannot fill up are a 2 by 2, 2 by 4, 2 by 7, 4 by 4, and a 1 by 3p plus 1 and 1 by 3p plus 2. And these two, we can't put any 2 by 5s in, and note, we can't possibly fill them in by 3 by 1s because the area is not congruent to 0 mod 3, and filling it by 3 by 1s only fill up something with area congruent to 0 mod 3. And a lot of these, note, we can put in either 0 or maximum 2 by 5, and in either case, you'll see we cannot fill in the rest with 3 by 1s. And that solves the problem. Thanks for watching. Check out centermath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.